Hey, everybody. In our final section of chapter 12, we're going to look at probability and odds. We saw earlier that probability is a fraction. It's a fraction when you take the number of ways of getting something you're interested in and divide it by the total number of ways that something could happen. So when you're making these sorts of calculations, you usually consider what's called a sample space. A sample space is all the different possible outcomes. So let's take a look at a couple sample spaces. Let's say we roll a dice. If we roll a dice, a normal six-sided dice, then our sample space is 1, 2, 3, 4, 5, or 6, right? Those are the 6 different things that could possibly come up. If instead we flip a coin, our sample space in that case is either heads or tails. If we flip a coin twice, then our sample space is either heads, right? We get 2 heads in a row, or heads, tails, or tails, heads, or tails, tails. Now, once we have a sample space, then what we usually look at is some smaller section of that we're interested in. And often that's called an event. And so if we roll the dice, right, we had 6 different possibilities. Perhaps our event that we'd be interested in would be that we rolled something even. And so if we have our sample space written like this, then we could circle how many of those contain even numbers. Or we roll a 4 or greater. So a 4 or greater, that would be these guys. Or we roll a 7. If we are just rolling 1 dice, well, then it's impossible to roll a 7. And so the event space doesn't contain any items in it. So with those ideas in mind, we can return to the idea of probability and see if we can calculate some probabilities. So our next example is what if we flip a coin 3 times? What's the probability that we get 2 heads? So a lot of different ways we could answer that, but this is a small enough sample space that I think we can actually list all those possibilities. So we could have heads, heads, heads. We could do heads, heads, and then a tails. We could do heads and then a tails and a heads. Or we could do heads and a tails and a tails. We could start off with tails and then do 2 heads. We could do tails, heads, tails. We could do tails, tails, heads. Or we could do tails, tails, tails. And that's it for our sample space. And now we can go through here and look specifically at the event of getting 2 heads. So to get 2 heads, there are, let's see here. Here's one way we could make that happen. Here's a second way we could make that happen. Here's a third way we could make that happen. So there are, in total, 3 ways of getting what we're interested in. And there are 8 total ways of having 3 heads be flipped, or 3 coins be flipped. And so the probability here would be 3 over 8. So a lot of times probabilities are written as fractions like this. But a lot of times probabilities are described as percentages too. So if I divide 3 by 8, that gives me 0.375. And if we describe this as a percentage, we can move that decimal spot over 2 spots and write this as 37.5%. So either 3/8 or 37.5% would be good answers for this question. In example 3, we're going to look at what's the probability if we roll a pair of dice that we get a sum of 8. So in this case, the sample space contains 36 different options, and a good tool for describing and organizing the sample space is to make a table. So we have on the side here rows that represent the first dice that was rolled. And as columns, we have the second dice that was rolled. And we can then take 6 times 6 and realize there's 36 different ways that 2 dice could be rolled. So that'll be the denominator of our answer. And if we look more carefully, we're going to look through here and see the event that we're interested in is when the 2 dice add up to 8. And so here's an option where they add up to 8. And here's an option, 3 plus 5. And here's an option. And the neat thing about this table is that those options end up lining up along this diagonal. So it looks like there are 5 different ways that we can roll an 8. And so the probability of getting a pair of dice to add up to 8 would be 5 out of 36. So 5 out of 36 as a decimal is 0.13888888. So 0.13888 and so on. And so that would be written as about 14% probably. For example 4, we're going to look at, if we're playing cards, what's the probability that we draw 2 hearts in a row? So if they give us a heart and then we take another card and that's also a heart, what's the probability of that happening? So there is a little bit of a wrinkle to this question, and that is, does the card that we get put back into the deck and we can draw it again, or does the card that we get go into our hand and then we're left with something else? So that in these sorts of questions is when they talk about with or without replacement. So I'm going to start by thinking about with replacement, which means we get a card, we take a look at it, and maybe we use it and we put it back, and then we get another card, and it's possible that maybe we get that card again. I'm going to do that just because it's easier math, but then we'll look at what happens without replacement. So, all right. So if we think about putting the card back, which means we can draw it again, then it's kind of like the dice rolling problem, only a lot bigger, because there are 52 different cards that you could get, and those 52 cards for your first and then 52 for your second, that's going to be a lot of possibilities, and I'm not going to list all of those out with a table. However, I think I can still use a table. So I'm going to try to draw a table here. But instead of listing all 52 possible cards this way and all 52 possible cards this way, let's look at how many of those cards are hearts and how many of those cards are not hearts. We'll do the same thing for our second card, hearts versus not hearts. So there are 13 hearts in a normal deck and 52 cards in a normal deck. So that would mean 52 minus 13 is 39 cards that aren't hearts. And for our second card, there would be 13 hearts, and there would be 39 non-hearts. And as a whole, there are 52 total cards available. And there are 52 total cards available. And so if we want to know the total number of ways of getting 2 cards, we can multiply 52 and 52 together. 52 and 52, when you multiply them together, is 2,704. So if we are considering a card and then putting it back and so forth, there are 2,704 total possibilities. And now we want to know how many of these possibilities involve us having two hearts. So this section right here are the possibilities of us getting two hearts, right? This is ace of hearts and ace of hearts. This is ace of hearts and two of hearts. This is the ace of hearts and the king of hearts. This is the king of hearts and the king of hearts, right? So those are all the different ways of doing that. There are, if we multiply 13 by 13, there's 169 ways that we can get two hearts. So that's the ways that we're interested in, and we can put that here. And so if we allow the card to be put back and we can draw it again, then that answer is 169 out of 2,704. Now, most card games, you have a hand of cards. So you're given a card, and then it's not put back, and you're given a different card. And so how does that change things a little bit? Well, what that means is that we aren't allowed, say, to have this option in the top corner where we get an ace of hearts and then an ace of hearts the second time. Or we're not allowed to have this option, which is a two of hearts the first time and a two of hearts the second time, and so on. We can't have anything along this diagonal where we have the same thing happening each time. Likewise, we wouldn't be allowed to have, say, the eight of spades and the eight of spades given to us in a row. And so along this diagonal, there are 52 different possibilities that we have to remove from the table. And so we can do that. If we take 52 away from the denominator, then there's 2,704 minus 52 is 2,652 options now. And we also need to think about, in our hearts event case that we were looking for, there are 13 that were matches, right? An ace of hearts and then an ace of hearts, or a two of hearts and a two of hearts. So there are 13 possibilities up there that we'd have to take away from the numerator. So 169 minus 13 is 156. So then there'd be 156 ways of getting something we're interested in, and 2,652 total ways of getting cards. And so that would be the probability if you allowed, or if you didn't allow replacement. So anyway, just small little wrinkles you got to think about with some of these questions. All right, usually when probability is introduced, odds are also introduced. And so odds and probability are kind of describing similar things, but in a different way. So where probability compares the number of ways of getting something you're interested in divided by the total number of ways of getting anything happening, odds compares the number of ways of getting something versus the number of ways of not getting something. So again, similar idea, but a slightly different combination of things that you're told. When you're looking at odds, you're usually looking at the ratio between favorable and unfavorable. When you write it in that order, that's called the odds in favor. You can also talk about the odds against something happening. It's the same numbers, it's just flipped. You put the number of ways of not getting what you want over the number of ways of getting what you want. That's called odds against. Odds are never written as percentages. Odds are always written as a ratio, and so they're usually read as blank to blank. So you would say the odds are 5-1 or 3-2. Sometimes that's written as a ratio with a colon instead of as a fraction. So here's a couple of examples of some calculations. And either way, I'm still going to be looking at how many ways there are of getting what I want, how many total ways are there, and then I'll usually subtract those to figure out how many ways there are of getting what I don't want. So let's look at the odds in favor of rolling a 7 if we roll a pair of dice. And to do this, a pair of dice, that's 36 different ways of making something happen. Let me sketch a quick little table of all that. So we've got 1, 2, 3, 4, 5, or 6 is our first dice. 1, 2, 3, 4, 5, and 6 is our second dice. And there are, 6 and 1, or 5 and 2, or 3 and 4, or 4 and 3, or 5 and 2, or 1 and 6. Those are the different ways of getting a 7. So there are 6 ways of getting a 7. There are 36 ways total. And if I subtract those, there are 30 ways of not getting a 6. And so knowing these 3 numbers, now I can write either probability or odds in favor or odds against. It all depends on what you're asked and what you're interested in. So if you're interested in odds in favor, so odds in favor is the number of ways of getting what you want versus the number of ways of not getting what you want. And so the odds in favor would be written as 6 to 30. In our next example, we're looking at what are the odds against pulling out a ball that is a certain color. And so we have 3 red balls, 4 white balls, and 5 blue balls all placed in a box. And we're going to just pick one out randomly. What's the odds against that ball being blue? So let me draw a box, and I'll put in some red balls, and I'll put in some white balls. Sorry, the white balls are a little bit hard to see here, I guess. And we'll put in some blue. And again, I'm going to be interested in what are the ways of getting blue, what are the ways of not getting blue, what are the ways total. So in this problem, there are 5 ways to get blue. There are 7 ways to not get blue. And there are 12 ways total. And so we don't need the total since we're looking at odds. Odds against is going to be, there are 7 ways to not get blue, and there are 5 ways to get blue. So it would be 7 to 5. Now, usually, a useful skill is if you're told what the probability of something happens is, can you express that as odds? Or if you are told what the odds of something happening is, can you express that as a probability? And these are the formulas for odds and probabilities that are presented in books. I don't remember these formulas. I don't recommend that you try to memorize these formulas. I would suggest that you think about their definitions, right? That probability is the ways of favorable divided by the total. That odds in favor are favorable versus unfavorable. Or that odds against is the other, unfavorable versus favorable. And then the key idea will be to remember that the total number of ways is just what these guys add up to. So if I'm told 1, I'll usually try to figure out the other by doing either some adding or subtracting. So in example 7, we have a horse racing situation where they're always talking about the odds against horses winning. So the odds against a particular horse winning were 12 to 1. And so we wanted to know what's the probability that that particular horse wins. And so if it says odds against, then that means 12 is the unfavorable outcomes, and 1 is the favorable outcome, meaning they win. And if we add those together, that's the total number of outcomes. And so the probability of Drosselmeyer winning is favorable divided by the total. And so favorable divided by total would be 1 over 13. So there's the probability of that particular horse winning. And in our last example, we've got a prediction made that the probability of a big one happening, a big earthquake happening within the next 30 years is 60%. And so perhaps to tell people or to communicate that danger to people, we want to describe that as the odds in favor of an earthquake like that happening. So I'm going to take this percentage that's given to us. So that's the probability. Probability, remember, is favorable outcomes, which is hard to say that an earthquake is favorable. That sounds like a bad thing happening. But anyway, that's what we're interested in, right? So the number or the ways an earthquake happens divided by the total number of ways. So 60%, we can write that as a 60 out of 100. So 100 would be total, and 60 would be favorable. So that's what this 60 represents. And if we want to describe odds, we need to think about what is favorable versus unfavorable. So when we remember that unfavorable and favorable add together to give me total, well, that means I can subtract to get unfavorable. So unfavorable would be 100 minus 60. So 100 minus 60 would be 40. And so finally, I can now describe the odds in favor of something happening. So the odds in favor means the ways we're interested in versus the ways we're not interested in. And so that would be favorable versus unfavorable. And so that would be 60 to 40. And you can either write your answer like that, or this ratio can be reduced a little bit. You could divide them each by 20, and you could write this as 3 to 2. So either of those ways of describing the odds would be fine. Anyway, there's a couple of examples of probability and odds calculations. And so good luck on your homework. Let me know if you have any questions. I'll be glad to help. Have a wonderful day.